Upon receiving an inquiry, Soil Science will arrange for their expert team to visit the potential site to ascertain the viability of their SUREGROUND reversible soil enhancement system. They will assess the terrain and obvious ground conditions in conjunction with any soil investigation report that is available. Following this, a full geotechnical proposal is drafted, which will include a ground design giving the end strength required for the temporary works traffic being used on that job. Strengths can vary from 15 to 100% CBR, subject to specific requirements. On receipt of confirmation to proceed from the client, DCP or dynamic cone penetrometer testing is undertaken to 900 mm to establish the ground strength of the formation of the enhanced layer. This is required as compaction is a vital part of the soil enhancement process. Material samples are also taken from site and delivered to a laboratory to confirm proposed mix designs. Varying addition rates of SUREGROUND binder are added, and this validates that required strengths will be met prior to commencing works on site. Sulfates, nutrients, pH levels, organic matter and plasticity are also tested for. Nothing is left to chance prior to commencing works. On receipt of an order, Soil Science can mobilize to site within 7 days. An on-site laboratory is set up. Topsoil strip of the set-out areas is undertaken. Mixing commences using specialist plant, a stair dust-free mixer, which can rotivate SUREGROUND binder into the soil up to 350 mm in depth at predetermined addition rates via an onboard system. Correct moisture content is another vital part of the soil enhancement process. Water is added if necessary. The area is then trimmed, compacted, trimmed again, and finally compacted with a 13-ton vibrating roller. A number of surfacing designs are available. Standard stone design. 100 mm of primary type 1 stone is spread onto the curing enhanced material and is compacted. Consequently, this cures together with the enhanced layer, giving a robust, virtually maintenance-free, very durable surface. This is suitable for short to medium-length programs. Surface armoring design. Primary type 1 stone is laid over the enhanced layer, most often to a depth of 150 mm. This is then mixed with further SUREGROUND binder before bespoke specialist plant undertakes further processes, forming an armoured surface which is completely maintenance-free, with a design life of a minimum of 2 years. Asphalt surfacing design. Asphalt can be laid directly onto the enhanced layer. No type 1 regulating layer is required, with achievable tolerances of plus or minus 10 mm. This is suitable for long-term works. Temporary haul roads can also be constructed to highway specifications and used as the capping and sub-base for permanent roads after their requirement as a haul road has expired. Given optimum conditions, 3,000 square meters or half a kilometer of haul road per day per gang can be completed. Throughout this process, on-site testing by a UCAS-registered laboratory is undertaken. Moisture is constantly monitored to confirm that vital compaction is being successfully achieved. UCAS validation testing is undertaken after 48 hours to ascertain required CBR strengths have been achieved, after which site trafficking can commence. The process is complete. Once temporary works have been completed, Soil Science return to site to undertake decommissioning. Prior to the decommissioning process commencing, Soil science has taken samples of both virgin soil and enhanced soil in order to analyze difference in pH levels, nutrient values, and other properties. A meeting is requested with the main contractor and/or landowner to discuss exactly which grass seed or crop is to be planted after the soil regeneration has been completed. This data, obtained in the testing process, is then used to formulate a bespoke reagent blend, tested within laboratory conditions, assessing the changes in the soil makeup after construction and proving the return of pH and nutrient to their original values. The first part of the process is to strip the stone surfacing and to relocate this. Most often it is donated to the landowner or to a local contractor for reuse. A subsoiler is then employed to both relieve any heavily compacted areas and to break up the enhanced subbase. This will operate to a depth of approximately 350 millimeters. Nutrient and pH levels are returned to original values by the introduction of the site-specific reagent, which is mixed into the enhanced material using a stir dust-free mixer, giving optimum fertility back to the landowner. Testing will now be undertaken to validate these levels. Topsoil will then be quantified and spread evenly over the entire area using the required plant for specific sites. A power harrow will now be used to cultivate the soil, providing a healthy tilth in readiness for seeding or planting crops. Depending on the time of year, grass seed will now be sown. This can be undertaken between March and October, or the land is handed back to the landowner to plant crops at their convenience.